G'day there. Today we're going to be doing a video on voltmeter impedance and how to test it and measure it. It turns out it's actually a pretty important thing to know if you're going to use a voltmeter, because your voltmeter could be interfering with your measurement. It could be throwing your readings out, or it could be causing interference with a circuit if you're measuring something in a running circuit. And I was trying to explain this to a friend and how to test it, and I went to do a Google search to see if I could find some instructions on how to test the impedance of a voltmeter, and I didn't find any results. So I thought I'd better put this video up and explain to everyone out there how to test the impedance of a voltmeter. So we're going to start by using this meter here, which is my good quality meter, to test the ohms of the voltage inputs of the other meters. That meter's got a backlight and it should be reading 0 right now, but I think I've got something going on with one of the connections. There we go. So let's start out with this cheap little $3 piece of junk. So I'm going to set this meter that's going to be doing the reading to the ohms range. I'm going to set this meter that I want to test to the volts range. I'm going to place my test probes on the inputs for the voltage range, and straight away we can see that I have 1 million ohms. Just shy of 1 million ohms, and that's probably, again, bad connection. There we go, 1 million ohms. There is an M up there of resistance on that voltmeter. And on the voltage range of your typical multimeter, that will stay the same. Try and get this where the light's not glaring on it. There we go. So it was on the 500 volt range, now it's on the 200 volt range. And you'll start to notice a 0.2 of a volt starting to show here. If we go down to the 20 volt range, it's saying 0.25 of a volt. 0.24 of a volt, that's actually the test voltage this meter is using to test the ohms of this meter. And how the voltmeter works is just a resistor network inside here, and it actually measures the current travelling through part of the resistor network and does some maths and works out the voltage. So if I go down here, we can see that that is definitely 0.24 of a volt being used as a test voltage by this meter here to tell us that there is 1 million ohms of impedance across this voltmeter. Now that's pretty good. That's, it's not ideal. So the really good meters like this one here have a 10 million ohm impedance, and I'll test that with one of these meters in a minute. But that's not too bad. Nothing to sneeze at. And something else I just want to demonstrate is that the current readings, current sense resistors on these meters often have very different resistances to the voltage measuring range. So here it's saying, I've got a bad battery in this meter, falls in and out, but it's saying pretty close to 1 kilo ohm, 0.9978 kilo ohms, 997.8 ohms is the voltage measurement, is the resistance measurement of the current sense resistor when I'm on the 200 microamps range. If I switch to the 2000 microamps or 2 milliamp range, then it drops down to 100 ohms. If I switch around to the 20 milliamps range, then it's a 10.4 ohm resistor there that it's using to measure the current. The 200 milliamp range is a 1.4 ohm resistor. And then if I move that probe over to the 10 amp position and test the 10 amp circuit, I can see that the 10 amp circuit is 0.23 or 0.22. It should be usually 0.22 of an ohm resistance. But just over 1/5 of an ohm resistance on that 10 amp measuring circuit. And if we test this meter over here, we're going to get pretty much the same results. .1 million ohms on the voltage range. And that's the same 1 million ohms on right through the voltage range. And again, we're seeing that this meter's probably getting a flat battery and it's down to 2.2 volts test voltage. Or this meter's not quite, these cheaper meters might not be that accurate. But we know we're in the ballpark. I'm quite happy around that 970 to 80,000 ohms up to 1 million ohms. And I'll just unplug one of those and we'll switch around to the amps measuring circuits. I'm not sure if they actually work on this meter. I think I burnt them out. Yeah. You notice I'm using homemade leads on this meter. The original leads died a fiery death probably around the same time I burnt out the amps measuring circuits. This meter's an old one, I've had it for 20 odd years. And finally, let's have a look at this analog meter, which is what inspired me to do this video. Make sure I get the connections around the right way. Not that it really matters that much. And we can see this analog meter has a resistance of 30 kilo ohms. You can see a K up there. The camera will focus on it. And 30 kilo ohms is pretty typical of an analog meter. Some of them are 10 kilo ohms. And this can have a big effect on a lot of circuits. The meter still works fine, which is why I've got some batteries here to demonstrate. I'll put the meter on the terminals of the battery. And see that this flat 9 volt battery has about 4.5 volts in it. And this fully charged 9 volt battery has 9 volts. Great, just what it should have. But it can cause some interference with your circuit if you're using an analog meter with a high impedance, with a low impedance like that. Ideally, you want to use a meter like this one. Not always in everybody's budget. And then you can take much more accurate readings of your circuits without causing so much interference. And just for kicks, let's chuck this one onto the ohms measuring range. And we're expecting to be in the millions of ohms, so I'm going to set it to the 2 mega ohms range. This meter might not even have enough range on it to actually measure this meter. Let's see. Well, I'm measuring a test voltage, but no, alas, this meter is not sensitive enough to measure the 10 million ohms of resistance of this meter here. And this one only goes to 2000 kilo ohms. 2 meg again, so can't do it, unfortunately, today. But anyway, now you know how to test the internal resistance of a voltmeter or an amps meter, should you need to know that for any experiments or testing that you might be doing. Thanks for watching.